War. War never changes. Or does it? Yes, the essence of war remains the same. It's the highest form of competitive struggle. According to military theorist Carl von Clausewitz, it's an act of violence to subjugate the will of an opponent. It is the most dangerous, but also the most productive activity of human societies. War, whether we like it or not, sets in motion and changes all spheres of life: culture, social relations, and of course, technology. Technology has already twice in human history completely changed not the essence, but the very face of war. The first time was gunpowder. It changed not only the tactics on the battlefield. Firearms created new social relations and new power. It was not determined by origin anymore, but rather by who had the gun. The second time was nuclear weapons. It jeopardized the very existence of humanity. It also made a new full-scale war impossible, and instead came a world of cold wars, proxy wars, wars of terror, and hybrid wars, but never a direct war between high-tech powers. We live in a decade that could spawn several technologies at once that will change everything. Artificial intelligence, breakthroughs in robotics, physics, and bioengineering. Warfare will involve robots, drones, cyborg viruses, quantum computers, and new forms of intelligence. But the main thing in the next military revolution is to change the very concepts of war and peace. What technologies will be crucial? Some of them, for now, remain science fiction, but some are already being applied on the battlefield. What are the new possibilities and what dangers do they present? Is there any way to contain the arms race? And how will it change the face of warfare? We're going to talk about how the key technologies around which the battle for supremacy between states and other players are already underway today. And how it will end is up to you to decide, because man remains the main actor and the main target of this war. The war of the future, or the next war, was already talked about in the early 2010s, when it became clear that the end of history in the 1990s did not happen, and world powers will continue to compete for first place on the planet. The number of state conflicts has been growing since 2012, global military expenditures since 2014. By the end of the 2010s, it became obvious for all states that the conflict at the level of diplomacy and economy has its limits. And since the contradictions of the world do not become less, the probability of direct military clashes between individual large states and allied blocs increases. Already in November 2015, the US Senate held a meeting for its Armed Services Committee, with the stated theme, The Future of War. Senator John McCain opened the meeting as follows. Today we are focused on the future, on what will be decisive on the battlefields of tomorrow, what technologies our future warfighters will need, and how we can reform our defense institutions so that they adapt at the speed of its innovation, not bureaucracy. In attendance were the heads of committees responsible for cybersecurity, strategic investments, and representatives from foundations and academic groups within the US Armed Forces. Their task was to determine what the war of the future would look like and how to prepare for it. Even then, the military realized that the likely enemy in this conflict would not be insurgents with Kalashnikovs or the army of a shaky state frozen in the 20th century, but an enemy directly competing with the United States in high-tech fields. Promising directions were clear even then: big data and neural networks to help process it, unmanned aerial vehicles and robots to save soldiers, the possibility of autonomous combat systems that completely eliminate the human factor, militarization of space and warfare in a digital environment where reliable communications will be critical. By 2023, technological competition in each of these areas has peaked, and practical competition is already underway on the battlefields, for now in proxy conflicts. Drawing on reports from organizations and experts assessing the applications, limitations, and prospects of these technologies, let's find out what could change the rules of the game as early as tomorrow. The civilian sphere is abuzz with headlines about godlike artificial general intelligence, which is already close. Elon Musk said that it could appear very soon, as early as 2029, but the military does not take this factor into account, at least in public reports. At the same time, back in 2014, the very developments based on artificial intelligence were called by the Secretary of the US Department of Defense Chuck Hagel, decisive in the new generation of military operations. Plans for the introduction of military technologies in general are distinguished by their long-term nature. For example, China is using the developments on AI that began in the 80s. The main institutes and programs were deployed in the 2000s, and the plan for gradual modernization of the People's Liberation Army of China is phased until 2035. The role of neural networks and trained models in all high-tech armies is already great today, and according to all forecasts, it will only grow. AI is particularly useful in the task of intelligence and logistics, planning operation, and training personnel. An example of such integration of artificial intelligence systems is Palantir. No, it's not one of Saruman's orb from Lord of the Rings for you hobbits watching. It's an American company that's been developing solutions for interactive virtual analysis of large datasets since 2003. Let's imagine a battlefield. There are a lot of objects on it, and their location is constantly changing. A person simply can't physically keep track of everything that's happening. Here, intelligence systems come in handy. They allow you to collect disparate information coming from the battlefield, remove unnecessary noise, highlight changes, patterns, and anomalies, and give the superior officer at the command post visual clues with recommendations. Artificial intelligence is perfectly capable of handling monotonous tasks, allowing it to process massive amounts of data and eliminate errors due to human error, allowing the operator to focus on decision-making and battle planning. Palantir's solutions for 2023 are widely integrated in the U.S. military and intelligence agencies, and similar systems are used in the civilian sector, and manufacturing to prevent accidents, and business analytics, and finance, and government. But they have enough limitations. The first and most important is hardware. Despite the fact that the U.S. has the most military hardware in the world, the data that can come from it for AI training is not used, because what is needed is either lost or outdated. A lot of it is just somewhere collecting dust. And in the history of the Pentagon, the task of combining the information into one database has never happened. This is for numerous reasons, but mainly for security. This problem is temporary. It is solved by the modernization of equipment and structuring of databases. But the second limitation is more fundamental. The very nature of today's artificial intelligence models is such that they show good results on a controlled environment, but with a limited range of tasks while on the battlefield, conditions and tasks are constantly changing. AI is able to process data well and notice changes in it, but making adequate decisions, weighing all the pros and cons, taking into account all the nuances, and most importantly, taking responsibility for the result is not currently feasible and is not likely to be in the foreseeable future. The third factor is that intelligence systems can't be relied too heavily on in combat operations against a technologically comparable enemy. Since the 90s, the Pentagon has been conducting military reform in the concept of network-centric warfare. This implies intelligent information interaction between soldiers on the battlefield united in a single information network. When satellites, unmanned reconnaissance, and communication channels all allow individual units having more data on hand to act with a degree of autonomy. But if two forces using such systems clash, it opens up the possibility of exploiting their vulnerabilities, blinding and disorienting the enemy, leaving them without the usual support, for example, through electronic warfare or hacker attacks. As long as there's no artificial intelligence on the planet equal to human intelligence, humans will always figure out how to find blind spots in the enemy's systems and outwit them. In a speculative scenario, if someone achieves sufficiently universal artificial intelligence, he will have a huge advantage. But the fact that it will immediately end up in the hands of the state or leave the military sector is rather unlikely. Programs to support military development of artificial intelligence in the US have existed for about 10 years, and for the same number of years, there have been complaints about their inadequate funding, lagging far behind the private sector. US developers of general-purpose robots oppose turning them into weapons, while multinational corporations that lead the data market are bypassing large military contracts altogether. Corporations are focused on the global market, not the interest of a single state. In China, the army uses the model of private contractors, and most of the developments of the field of AI are created by extensive networks of private companies, including those working for the institutions of the Chinese army. And Chinese civilian sector has long since pulled ahead in data collection. So the chance that a general artificial intelligence will immediately gain access to nuclear codes is still pretty small. More likely, it's going to try to sell you something. Already today, AI systems are being used in warfare, changing fundamental approaches to intelligence, battlefield communication, and troop management. Going forward, all technologically advanced armies plan to rely more on intelligent systems, modernizing the technical base for data processing and linking troops into the military Internet of Things. With it, the military will have previously unprecedented battlefield situational awareness. So artificial intelligence is a reliable assistant in the near future, but key decisions will still be made by humans. The most important task in this case is to save the people in charge of these systems. The value of a military specialist's life is only growing. Unmanned systems, on the contrary, are becoming cheaper and moving from piece-to-piece mass productions. For example, in 2007, MQ-9 Reaper units conducted reconnaissance and carried out pinpoint strikes in Iraq and Afghanistan. Now, in the civilian sector, drones for photography, pizza delivery, and fishing are being mass-produced, while in the military sector, similar drones can take pictures of the enemy positions, deliver explosive, and rescue the wounded. Drones are effective in the task of cargo delivery, safe for the operator to hit targets, reconnaissance, convoy escort, and territory protection. They can do all of this in the air and on the ground, in the water, underwater, and even in space. For the first time, unmanned systems were developed. Together with satellite constellations, drones have proven to be indispensable visual control tools. They complete the picture of the battlefield in real time, and guided ballistic missiles and explosive drones demonstrate frightening accuracy. In large metropolitan areas, unmanned cars and trucks are being tested, keep drivers safe, and save transportation. The same developments are being created for military equipment, the cost of production of which and training of personnel is much higher. In the future, we can talk about unmanned tanks, transports, ships, airplanes as the norm on the battlefield. Today, the US has already developed about 36 unmanned drones for different combat missions. Russia is testing unmanned tank platforms. China is developing an aircraft carrier with drones on board, and Iran, Turkey, and Israel are all producing their own drones. But unmanned systems also have their limits. In a direct collision, unmanned aerial vehicles are inferior to a trained pilot, so auxiliary systems in large aviation will be developed, but in critical moments, there will still be an experienced ace at the helm, who, of course, if unmanned systems are available, won't be sent on a suicide mission, but rather saved for more complex and responsible tasks. Unmanned systems are also extremely vulnerable to electronic warfare. The people at the helm still haven't learned how to disable the interference. But to lose expensive equipment in the presence of an enemy that has adequate air defense, well, they're great at that. This leads militaries to the production of disposable unmanned systems, which, while expensive, are not as bad as losing real humans. But all this greatly limits the use of drones against a prepared enemy, and the modern battlefield is saved from swarms of drones circling in the sky day and night by the relatively short battery life, one of the biggest problems in recent years, and another area of the real technological race. Year after year, we're promised new breakthroughs in the way we store energy, and invest huge resources in doing so, but we're still mostly using lithium-ion batteries, a technology that hasn't changed much since 1991 when it was first introduced. The first such mass-produced battery was from Sony when it hit the market. In less than 10 years, drones have gone from being rare special operations assets and toys for civilians to a distinct type of weaponry, creating and occupying an important niche in the battlefield and opening up new possibilities for the use of military hardware. But a fully unmanned robot versus robot war is still a long way off. Humans on the ground still decide the outcome of battles and bear all the burdens of war. In 2022, a video called Slaughterbots by the Future of Life Institute, the same organization that recently tried to halt the development of systems more powerful than GPT-4, appeared online. It called for a ban on the use of weapons that use algorithms to make autonomous decisions to eliminate targets. Fully autonomous systems are a logical development of unmanned technologies, when the technology doesn't need or require to perform all the tasks. But when it comes to such weapons, complex moral, ethical, and legal questions arise. Who is responsible for robot decisions that could lead to unwanted casualties? How can these systems be secured against possible mistakes? Since 2017, Future of Life Institute, Stop Killer Robots, and other organizations have been actively pushing to ban autonomous weapons at the UN level, asking countries to join a convention similar to nuclear weapons. But most countries have their own developments in this area. The United States, Israel, Russia, and China, and all of them are still delaying the signing of such a convention. For a long time, there's been a debate about what should be considered an autonomous weapon. For example, the Israeli firm IAI was one of the first to develop and supply Herald drones, which operate on a shoot-and-forget principle, like a self-guided projectile. But since the decision to launch the target is made by a human being, this doesn't truly count as an autonomous weapon. The organization, Stop Killer Robots, advocates defining autonomous systems as having no meaningful human control. That is, if a drone can be programmed to destroy a certain type of target and make the decision to attack on its own, it's an autonomous weapon that should fall under the ban. While lawyers are sorting out the term, the development of the use of autonomous weapons is in full swing. UAVs and guided ballistic missiles of varying degrees of autonomy are produced by Israel, Russia, China, the United States, Korea, the United Kingdom. The list goes on. Autonomous weapons can technically be considered smart mines that are triggered when specific parameters are met. The Mine Convention at the UN in the 90s, by the way, also failed. The Ottawa Accords were signed instead without the US, Russia, and China. There are also compromise proposals to allow the use of only defensive autonomous systems, like Turkish patrol biplanes or automatic air defense systems, or to use them only against other machines and robots. But here comes the biggest potential danger of autonomous weapons. What happens if the autonomous weapons of two countries collide and decide to start a war without the knowledge and consent of the people? Such a situation could lead to a major conflict, up to and including nuclear escalation and World War III. For now, the legal status of fully autonomous weapons is not yet clear, and fully autonomous systems are still more of a speculative danger. All the big players, although not entering into conventions, have their own ethical principles for restricting these systems in their decision-making. In the near future, self-guided missiles and drones will be tested, and their use will expand. Such technology is especially valuable in hard-to-reach areas. Deserts, the Arctic, underwater, and the launch of ships with autopilot can help save a lot in the cost of maintaining sailors. They are also good for simple tasks with a set scenario, such as patrolling and guarding objects. And whether uncontrollable swarms of killer robots are waiting for us in the near future, the actions of which can be anonymous and unpredictable, will be determined by the development of artificial intelligence algorithms, as well as the ability to create dialogue and trust in each other as the main producers. The topic of space militarization has not been discussed so actively, probably since Reagan and Star Wars. The main emphasis in the technological equipment of the future wars is placed on communications, and reliable satellite communications is a priority. Recently, its capabilities and limitations have shown. Russia, China, and even Starlink from Elon Musk are increasing their satellite constellations, and other countries are joining the launches. Since the early 2010s, the total number of new satellites in orbit is growing from year to year, and not all of them are exclusively civilian. However, space is far away and hard to wage war in, and the defeat of the enemy's orbital constellation of satellites is still a purely theoretical scenario. Any space development is expensive and complicated, and in case of a global war, satellites are the first thing to be destroyed. We're still not sure how to protect them. Therefore, a reasonable solution is to create a backup protected ground-based communication system. Quantum communication can become a substitute, as quantum communication cannot be intercepted. They are instantaneous and reliable. At the same time, breakthroughs in quantum computing may in the near future turn the world to encryption, making almost all modern cryptographic methods obsolete. In the struggle of satellite constellations for a place under the sun, the most promising area looks like low orbits, where you can throw a network of small satellites, multiplying the accuracy of data and what is happening on real time on the ground. So Russia recently tested the first low orbit satellites, and no doubt others will soon join the exploration of these great heights. Cyber warfare will be to the 21st century what Blitzkrieg was to the 20th century. General V.P. Malik, Chief of Staff, Indian Army, year 2000. In addition to land, water, air, and space, modern military theory since 1995 has emphasized another area, information, or cyberspace. In it, operations are also prepared, specialists are trained, and war is waged, only not with kinetic, but with informational weapons. As people become more involved in the virtual world, the importance of this theater of war grows. And if earlier information operations were mainly engaged in intelligence, agents, and hacker groups, then with the new round of development of bots, neural networks, and opportunities for individual influence, it involves almost the entire population of the countries involved in the conflict. The forms of confrontation are extremely diverse. Recruitment of agents, sabotage, provocation, disinformation, and cyber attacks on digital and physical infrastructures. In recent years, there's even been a discussion on another dimension of warfare, cognitive, when it's the goal not to control the information, but to control the very thinking of the enemy. This makes more sense. If more and more of an individual's environment becomes virtual, then his thinking is controlled by the one who creates the environment. The main objective of cyber attacks and cognitive warfare is to suppress the morale of the enemy's army and the morale of its civilian population through available communication channels. The digital and physical worlds are merging more and more closely every year, which means the information infrastructure, data centers, and communications is as important as power plants and pipelines. The virtual world is taking on more and more functions, becoming more and more complex and more vulnerable, which means that the adversary, and not necessarily the state, will hit it. States are aware of this and are preparing to the best of their ability. For example, in 2021, Israel, together with the World Bank and 10 other countries, conducted exercises to repel anonymous cyber attacks, which rumor has it paralyzed the financial and banking systems of several countries, bringing them to the brink of economic collapse. In total, 3 critical technologies can be identified, which in the future may shift the main focus of combat operations into cyberspace. These are generative models and artificial intelligence, which will expand the digital world by an order of magnitude. Possible breakthroughs in human-machine interfaces, developments like Neuralink that could change the very way we interact with the digital world, and finally, quantum computing and quantum computers that will provide the necessary power for such a digital revolution. But what stops humanity from moving the future of war completely beyond the monitor screen is the one vulnerable node that resides in the physical world. The energy infrastructure, if it is destroyed or damaged by a coordinated cyber attack, the most advanced digital systems will turn into useless scrap metal in an instant, and virtual violence will immediately revert to the real thing. The Center for Strategic and International Studies' April 2023 report, 7 Critical Technologies to Win the Next War, recommends that the US government and the Pentagon focus on 7 key technology areas. Here's a list of them. Secure and reliable communications, quantum technologies, bioengineering, cosmic technologies, high-performance batteries, and artificial intelligence robots. In total, scientists identify 56 specific technologies, the possession of which will be a serious competitive advantage in the war of the future. In this medical standings of the technological race, the states will follow each other, gradually introducing new technological means into their armies and trying not to lag too far behind their nearest competitors. The player who becomes the first in the few key technologies may gain a serious military advantage. The one who fails to move quickly enough into the next technological era will likely cease to exist. At the same time, warfare will not change beyond recognition in the near future. It will combine the elements we already know: trench fighting of the First World War, mechanized attacks of the Second, and guerrilla actions of the Cold War, and then modern cyber warfare. But there will likely be no bright nuclear outbreak of World War III. Instead, it will slowly smolder, spreading wider and wider by general instability, rebellions, and localized conflicts, in which more and more technical means will be used. Nuclear deterrence will gradually recede into the background, but it is still a guarantee of mutual destruction. And as long as it does, new types of warfare will emerge to circumvent it. The real technological revolution is taking place every day before our eyes, in the civil, military, and spiritual spheres, through the merging of the digital and analog worlds, the blurring of the very line between peace and war, in which literally everything becomes a weapon. From a post on the internet to a digitized DNA sequence, and everyone from a housewife with a smartphone to a soldier in the line of fire is an equal participant. The main element of the tectonic shift that is changing the face of the war right before our eyes, just as gunpowder and the splitting of the atom once did, is data. All the technologies described in this review are just private attempts from different sides to ride this new element, in the struggle for control of which between states, corporations, shadow structures, and individual, the main conflict of the 21st century is outlined.